So after we extract the LBP feature for the current image, we should store it in a variable. I use feature set for this purpose, and as you can see there is a index counter here, and it will be incremented by 1. After I read the first image, the next feature vector will be stored in feature set index 2. So I will repeat this operation over all of the images in the training set. This is the training part. Now for test the accuracy of the model, we need to test the samples inside the test set, and the system will predict the subject for each of the samples, and we will test it if it is exactly the same as the annotation data for the sample. It will be assumed as the correct classification, otherwise it will be considered as incorrect classification. So we have a loop again here over all of the images in the test set, read them one by one, again extract the same feature as we extract from the training set with the same parameter. Then we should find the similarity between this feature vector and all of the feature vectors that I have in this variable feature set, and find the most similar one. For this purpose we can use different metrics. I use Manhattan distance. So I will compute the distance between this feature vector of the current test sample, with all of the feature vectors that I have in this variable, and I store them in the distance variable. Then I will find the minimum distance in this array. Also I save the index of the element with minimum distance. Now I will check the annotation data of this subject and the subject in the test set. Ix is the index of the current test sample, and this index is the label of the most similar feature vector in training set. I will check the label of these two samples. If they are equal, it means that the system successfully recognized this image. Otherwise, I will add 1 unit to the incorrect variable. I will show these two unmatched subjects in order to verify it by eyes. Then we repeat this procedure for the next sample in the test image. And finally, we can compute the accuracy by dividing the number of correctly classified or correctly recognized samples over the total number of correct and incorrect. So let me run my program. As you can see, we have 8 incorrect recognized objects, and the accuracy of system is 95%. Let's see the samples that are not correctly recognized. This sample belongs to subject 1, and the system recognized this subject and this subject are identical, subject 1 and subject 13. Again, another misclassification between subject 1 and subject 16. Another misidentification. Subject 16 and subject 36 are assumed as the same person. As you can see, these images are very similar. So even for the human, maybe it is hard to recognize them correctly. But only we have 8 incorrectly recognized image. Subject 36 and subject 17 are assumed as the same person for this image. These two guys really are very similar. Also these two guys. So in 95% of the time the system correctly recognizes the image. You can investigate the effect of changing the parameters of the feature extractors. For example, here the cell size is 32 by 32 pixels. Let me change it to the smaller size, 16 by 16 for both of the training and testing. So now my image will be divided into some patches with the size of 16 by 16 pixels. Run again your code. This time the accuracy increased to 99%, 99.38%, and only we have one misidentified image. Subject 1 this sample and subject 16 this sample are recognized as them belongs to one individual. Also, you can change the number of samples in the test set and train set. For example, if I only use 10% of images for training and 90% of the images for testing, of course your model cannot learn sufficient information from this 10% of the image, and the accuracy will be dropped. Let's check it. As you can see, the number of incorrectly classified or identified images are much more than the previous example. In this scenario, I use only 40 images for training and 360 images for testing. So the accuracy of this system is 69%, and we have 111 subjects which are identified incorrectly, and all of them are displayed here. And if I use, for example, 90% of the images for training and only use 10% for testing, of course the accuracy will be increased, because the model can learn sufficient information from 90% of the images. So the accuracy is 1. If you want to use another feature extractor, you can easily change this line. For example, I want to use the Hawk feature descriptors. And let's check the performance of this system with 60% of the images for training and 40% of the images for test. Till now 6, 7. I think we have 7 incorrectly identified. Yeah, 7 subjects are identified incorrectly. These two, this one, subject 10 and subject 4, subject 16 and subject 13, they are very similar. .95% of the subjects are identified correctly.